So let's go ahead and get started. I did not say the title out loud before selecting it, but you all are here for collaboratively building design-first APIs with OpenAPI. But also at GlueCon, this has been great because I've been having a lot of conversations that are like feeding into this talk, so great place to be. So let's get started. So traditionally, design work is something, you're making decisions about how something looks or how it feels and how it's used. For API design, there's a little bit of a constraint to that. It's more about decisions you're making when designing the API's interface. At least that is how the latest O'Reilly book, Continuous API Management, has been talking about it. And I love that book, so there's a few sprinkled quotes throughout. And so for many users of your API, the interface is the API. And one part, though, to that is what exactly then makes a good interface. I really like that it's one that makes it harder to do the wrong things and easier to do the things that solve the user's problem. So lower development effort on both the consumer and the producer side of things. And so with this, hence the growth of developer experience, which is pretty obvious to a lot of us as we've seen APIs grow over the last few years. And people at GlueCon, they're thinking duh, we've been talking about this for a while. But we have that conversation, I still feel over and over again, who has good developer experience? And we say the same people. It's, it's Twilio, it's SendGrid, it's Stripe, it's all the go-tos. There's this idea of UX collaboration tools, So when you think about it, developer experience isn't really that different from user experience. And when you ask people, what's your tool set for designing UIs, there's dozens and dozens of responses. And there's some similarities, but these exist. But what is that for API design? And specifically, we're talking about HTTP APIs for the purpose of this talk, but a lot of the ideas can cross over into other architectures. I believe that starts with an API description format. We need something to build the tooling around. In our case, for the purpose of the next 20-something minutes, this is OpenAPI. And so just to kind of get a gauge, who feels, I'm not going to actually call on you to answer this, who feels like you could answer this question of what is OpenAPI or Swagger? Raise your hand. Okay. Who is using it right now in your role? Okay, a couple less hands. Who's using it in your role for something that is different than API reference documentation? Okay, this is a lot less hands, but this is what I usually see. So I was first introduced to API specs through API Blueprint about 4 or 5 years ago. And I was trying to document an API that we were working on that we were wanting to open up publicly. And it was a really painful experience to do this from scratch. I'm glad to say the tooling is much better today. But for those who don't know, although that's a smaller number, so this shouldn't be earth-shaking, it's a standard structured approach for describing APIs that is both human and machine readable. It's description of specific properties that machines can process, and also a single source of truth that then we can all build around. Initially, it was called the Swagger specification. It's now a vendor-neutral specification under the Linux Foundation, and Swagger's more a brand of tooling. And historically, it has been seen as a thing to auto-generate API reference docs, because we all know developers hate writing docs. And it's kind of got a reputation for that. A very high level of V3 outline. The most important part is components. That's response body, parameters, examples, links, all the good stuff. Here is, I had to continue handwriting everything, so I had to write YAML by hand, which could have been written in JSON, but I didn't really want to write all my curly brackets. And so it's the API operations, it's the responses, it's the requests, all the good stuff. But most importantly, it's also things like shared schema for objects, like errors, or using references to be able to reuse these models and not have to rewrite schemas over and over again. So why do I care about this stuff? So I'm the lead community engineer at Stoplight, where I help hundreds and hundreds of people write OpenAPI on our platform. But really, I feel like I'm trying to create better API experiences, because that's what I really care about. I come from the background of working at a few different API companies, like Keen.io, And at Keen, I helped manage SDKs and docs where I felt a lot of the pain points of not having a specification. So a lot of the things that I'm talking about are things that would have helped my struggles. And so with that in mind, how does OpenAPI make some of these, how does it solve some of these problems? This is a very simplified, workflow, but I want to focus on the top part of that. So having OpenAPI, it feeds into a lot of different areas. Whether it be today we're focusing on design, because that's all we can do in 30 minutes, but also that can lead into server stubs once you have the specification, or generating test cases, or SDKs, or client libraries. Another thing is it's very much like a development contract. So if we focus on that design phase before the build, ideation's very kind of glossing over that, but we prototype our API design in the spec document, and then we iterate it collaboratively with having documentation available to us and instant mock servers available to us with different tooling. And you'd be like, yeah, that seems pretty simple. That's not hard to do. But what do you do when there's dozens and dozens of these APIs? How do we control this? And so I very much believe that API design at scale is only possible with the right tooling and workflow. So what are we looking for then? A lot hinges on this idea of a single source of truth. When I first started using specifications, that was not something I was introduced to, because to me it was just API reference documentation. Like a very common wordy definition of single source of truth is the practice of structuring information models and associated data schema such that every data element is stored exactly once. I think it's a super wordy way of calling it a contract, something that a group of people agree on and that we work around. To some users, right now, that might be API reference docs, whether those are accurate or not, which we can talk about. But we need to find something that is our single source of truth across many APIs. And so it's not just about the API references. To me, it's more than just a technical representation. It ends up being so much bigger than that. It becomes a tool for collaboration. So filling in a spec is kind of like filling in a form. It helps you describe an API. It gives us language. It standardizes terminology. So I was in a Slack conversation with someone, and two people were talking about operations, but they were using totally different language, and they didn't understand that they were talking about the same thing. But if they had some kind of centralized terminology to use, all of that 30-minute conversation would have happened in 5 minutes. And so it reduces a lot of that friction between teams or between partners. And so there's this really great quote from Ken Lane that OpenAPI is a bridge to understanding and being able to communicate around using HTTP as a transport, and our greatest hope for helping people learn their HTTPs and 1, 2, 3s. And that's a very grand mission, but I see APIs as this intersection between humans and machines, and having a specification kind of builds a bridge between those two. It's a development contract that removes silos between teams, so then we can all work around the same single source of truth. So we need some place to start with that. Typically, people are getting their specs 3 different ways. They're automating it from code. They're using design first principles. They're designing it before they even write a line of code. Or they're creating from scratch after, which I think is the most painful of them all. And if you've ever been there, which I've talked to some people here today, I empathize. But I want to focus on the second one. But I do want to say that automating from code can occasionally be useful if you need something to bootstrap. Now, don't be shocked that some of the tooling out there gives you invalid specification. Or maybe your API isn't actually OpenAPI compliant. Those are things you're going to have internal conversations about, like, do we make changes here? So where do we bring everyone to build this consistent thing? And that is an editor or a designer. Some of the requirements, I think it needs to be able at least to validate the document at minimum. It needs to make you an OpenAPI expert so that more people can participate in the API design instead of only the people that understand the specification. It also it ideally has ways to review whether that feeds into GitHub and your version using version control or some other kind of tooling. And then bonus points if it has a way to have common libraries so that you can practice reusability across APIs within your organization. At Stoplight, we have a form-based designer that right now we have in beta that you're happy to come play with at our booth. There's things like Swagger Hub, or maybe your IDE has a plugin that you like. All different choices that you can explore for what works for your team. Next, you need a linter to sit on top of that editor or designer. So a linter is acting kind of as a style guide. And it can include vocabulary, or maybe you're using camel case versus snake case, or different style choices, or interactions that kind of you would deem, this is what we would like to go towards in our APIs. One thing I've seen often is sometimes things call themselves linters, but they're really still only validating the JSON or your spec. So watch out for something that actually allows you to build out a style guide. Tools like Speci, we work on Spectral, which we're now in V3 at Stoplight. They're both open source. And if you're producing many APIs and users are jumping across those APIs, the consistency becomes a lot more important. Because if they're jumping, there's a lot of cognitive load of switching between styles. And so being able to remove that cognitive load can make development a lot faster. So one of the things you kind of have to decide is, are we going to centralize the design work, or are we going to give centralized selection of choices to designers? A lot of developers don't like being told what to do, especially when it comes to their code. And so I have found it great to give those options through a style guide, but also finding ways to involve the developers in that style guide process so that they feel bought into the design. And it isn't just something that was dictated from above. So once you got your spec, you're starting to get all these other things. Instantly, you became a lot more powerful. You became the 10x engineer. And so I want to focus mostly on the rest of the design process, but I just want to touch on the fact that then you can start generating server stubs and other things that mocking that we'll cover in a minute gives you. And so yeah, you become a lot more part of the development process becomes a lot easier, is what. So I honestly think that mocking is the most underutilized feature, or not really feature, thing that you're getting when you have a spec, tooling that then doors are open to you. At Stoplight, we say that mocking is routing incoming requests to example responses, or dynamically generating examples on the fly. So things, you curl a request, the mock server looks up in the document, it either is dynamically generating something or using a pre-existing example. And that might also include different business logic, like min and max, different kinds of formats, stuff like that. There's a few different mock server tools out there. We've had one for a few years called Prism that was written in Go, and we recently rewrote it to TypeScript, and it's now in alpha. And we've kind of pared it down so that we focus on the mocking part of it even more. And depending on your role, mocking can be important to you for a lot of different reasons. So I usually say, try to find what that thing that clicks with the developer on your team, because sometimes they don't necessarily see it right away. So if you're using internal APIs, including if you're building out SDKs, it helps you build faster. So you can start parallelizing some of the development process of both the consumer and the provider side of the API. So after mocks are set up, then a team that is consuming that API can start hitting that mock server. The topic of whether you partially or fully or not auto-generate at all your client libraries or SDKs is a whole nother conversation, but at least having a specification allows you to have more options there. And have that conversation within your team to see what works for you. And then, so just a lot more options there. So I know this is kind of simplified, but a very more traditional, if you don't have any mocking ability, you get a very kind of waterfall-esque development process. Because every team is waiting on the team before it to finish that back-end implementation. With mocking, this is best case, but at least you can get a little bit closer to this so that teams that are consuming the APIs actually can start doing work instead of just having to wait. One of the things that I've been seeing a lot more requests from front-end engineers asking for the ability to mock their APIs so that they can do some of these things. If you care about developer experience or advocate for users, which is hopefully everyone here, being able to get early feedback and help influence the API before it's released can be so critical. Mocking can really help put like real endpoints in front of users, some of these like hypothetical features that you're like testing out with them. And one important detail is you can still get mocking functionality from like a code-first approach, but you're going to have to write more code to do that, and so that kind of defeats some of the purpose of saving time. There's a really great blog post actually by Lorinda about API design through feedback loops that I highly recommend, but it really can kind of feed into this idea of how having this like mock or experimental API can help your team. And one of the things I often think when we're building APIs we forget is that the people really consuming our APIs, even though we're telling computers to do stuff with them, is the humans. Since APIs are that mixture, make sure to get early feedback from people in teams that didn't actually build that API. Around how, is this actually what they want? Is the design make sense to them? Sometimes we forget to do this. We get so bogged down in the design within our teams that we forget who the actual consumers are. And it also helps buy-in, especially if it's internal APIs. Maybe you go talk to a different team. You can get buy-in on that API from them. So some of the questions I think to ask, since there really isn't what is a good interface, it's not like set in stone, you need to kind of think of what are the goals that your users have, and what are those tasks? What do we need to accomplish? And so then, does the API actually help them accomplish this? What calls do they need to make to accomplish that task? Did something that maybe should have been in 2 calls ended up being in 5? That's a conversation to have. And related to that, are the endpoints confusing? When you're on your team, you have a lot of insider knowledge, and it's kind of a curse. You need to ask people who don't have that experience, can they still understand what they need to do? Are things consistent across APIs? Are you following some kind of standards? And then the last piece with that iterative feedback is the documentation. So I often think we forget people within our organization that have who could really contribute a lot. For me, that's technical writers. Technical writers are users who did not develop the API, but they're going to have to explain it to someone. And so they can really have a great outside perspective that they bring something to the table. And then the other thing is, even though we aren't really practicing what some may call documentation-driven design, where you write the docs before you implement something, you are kind of getting that with being able to auto-generate the documentation from the specification. So this is like a lightweight process, so maybe for like a internal API that only your team is using. We write the spec, we mock it, we get feedback, we iterate there, and then we pull requests, and maybe there's a team of people who say, yeah, that design looks good. And also in that pull request process, it's being linted to make sure that it followed some kind of style guide for consistency. A more heavy-duty process for maybe an external API that is a lot more critical to your business would be, you're starting with high-level concepts. So, talking to the design, in the design meeting, having all the stakeholders there. They might be from across the business. This is even before touching a specification. And defining that vocabulary, and then talking to the users. And then you can start writing the actual specification document. And then using the mock API, bringing it back to those users and saying, does that actually do what you told me you wanted to do? And then seeing, a couple iterations there before following like the same process. One of the things also I've seen a lot of times when you start mixing together the high-level stuff and the low-level stuff, you forget what the task you even needed to accomplish was. So making sure you kind of split those out can be really helpful. So I really like this idea of having public OpenAPI documents as a form of continuous feedback. It can be that centerpiece. So people can actually comment on actual parts of the specification versus like giving you very vague design feedback like your API is confusing. That doesn't help anyone. Being able to actually narrow down to the actual places. And then also, I sometimes get pushback on this, like people are like, well, this is like insecure. I'm like sharing all these details. And I'm like, you're sharing a map, you're not giving the keys. API security through obscurity isn't great, so maybe you have bigger problems you need to take care of before you're concerned that you're like giving away all these secrets. And even though I'm mostly focusing on the design part of things, I really want to cover one bit into the build step. So this is also from the Continuous API Management book. No matter how great your architecture is and how maintainable your code is, if the API doesn't do what the design says it should, you've failed. So conforming to a published, or maybe not published, but some kind of agreed upon interface design or contract can be a really important metric, quality for your implementation. So whenever you update your implementation, you need to make sure that it's matching with the interface, or vice versa, which kind of brings me to this idea of contract testing. So contract testing is writing tests to ensure the API implementation meets the requests and the responses and the data types that were described in the contract. Testing has become a lot, especially in this world of service-based architectures and dependencies on different versions of APIs. It's really hard. You lose track of what is our single source of truth, because there starts becoming many of them. And so being able to rely on the spec actually being true becomes really important. And so that's why we need a contract test. And so with contract testing, you're taking advantage of that machine-readable portion of the spec. You don't have to write dozens and dozens of assertions for different properties because you already have that. It's written in your specification. And so while it is validating like the spec implementation, you're also validating your docs. You're validating potentially your SDKs. You're validating all the things that is built on top of that single source of truth. And so there's tools like Dread, which allow you to do this. Swagger Inspector, we do some of these things. We help people do them at Stoplight. They all can be very helpful. And then there's some like language framework specific stuff too. A high-level version of this would be something calls your API. Maybe that's your CI tool, and you get some kind of response. And then it gets compared by the validation server to the actual document. So maybe there was a missing property that was supposed to be required, so then that fails. So that tells you somebody screwed something up in implementation, and you're able to go fix that before it becomes a breaking change. And so if you're constantly having to fix these inconsistencies, you're really, that can really cause a lot of extra time to fix these bugs for your engineering teams. Why not just fix it before that was merged? I personally experienced this with SDKs, actually. Our PHP SDK at Keen had started behaving not like what the API was behaving like, or at least what the API was supposed to behave like. And a user was really confused. They're like, what is the right thing? And it turns out that 6 months earlier, a pull request had been merged to change the behavior, but it was something barely used. So only, it took a while for anyone to hit that specific case. But that could have been stopped at pull requests, because we would have been able to see, oh, the SDK is not responding in the way that the specification says it should. And so now, the reality of all of this. The question of who creates the spec is still open one in many organizations. Also developers are maybe not totally on board of this idea that they have to go do an extra step before they can start writing code. These are things to start talking about with our teams. But what I have really seen is find the thing that the developer's really struggling with. Whether they're annoyed at some of the bugs they're having to fix that could have been caught by contract testing, or something else. Find the thing that matters to them and show that to them. And then starting from scratch is also not really easy if you don't already have one. But many of y'all know what it is and are using it, so luckily this is not a situation as many of y'all are in, but that's still a situation that a lot of teams are in. The tooling today, it's starting to help more. I have also found project managers who kind of see the whole scope of how the API development process works, can be really great allies to bring on to help adopt some of these things. You know, ideally, things in best case scenario would look like something like this. But in reality, they look like something like this. We're going all over the place. But I think we need to start at least knowing where our end goal is to slowly, incrementally getting there on our teams and creating, you know, processes and using tooling that helps us potentially get there. So I like to ask this question of like, what would allow you to focus more on the API experience? When tooling is taking care of some of these things, then you can spend more time on that design process. You know, whether this be things related to linting or style guides, getting OpenAPI deeper into the development environment, CI/CD process stuff, testing tools. There's a lot out there that could be built. Some say that we should be building better APIs. I think we should build better API experiences because I believe that kind of brings down the silos of the process and puts the pieces of the puzzle together that create better API experience. So I've seen a lot of different environments on a day-to-day basis, a lot of different workflows, tooling. If, you know, I'd love to hear your struggles after, if you'd like to come up, or we can go outside and chat about it. And then if I don't have any ideas, or if I can't just empathize with your struggle and not have a solution, I also work with a lot of smart people who can also help me come up with ideas for you. I also think that OpenAPI.tools is a great place to start of a lot of different tools, different languages. And if you want to check out some of our open source projects, the mock server Prism, or the JSON object linter that helps you lint OpenAPI, you can check out our open source projects, or come stop by the Stoplight booth. That's it.